the first thing that we're going to look at are the trigonometrical ratios. All right, we're going to look at the trigonometrical ratios. So there are three most important trigonometrical ratios, especially at the grade level that I'm looking at. All right, at the grade level that I'm looking at, there are three important trigonometrical ratios. We are talking about the sine, we're talking about the cosine, and a tangent. So these are the three important trigonometrical ratios that we are going to look at. All right, so now these trigonometrical ratios, they have the way they behave in a right angle triangle. Okay, they behave differently in a right angle triangle. For example, let me put up a right angle triangle. All right, so in our right angle triangle, like the way I have this, and I'm going to pick any of the sides as my theta. Okay, so I've chosen to pick that as my theta. So with trigonometrical ratios, you need to understand that these sides have names under trigonometry. All right, this angle, its opposite, or the direct side of this angle is called opposite. All right, the direct side of this angle is called the opposite. Then where this 90 degrees points, the immediate side of that 90 degrees angle is our hypotenuse, which is considered to be the longest side of a right angle triangle. Then the remaining side is called adjacent. Okay, the remaining side is called adjacent. So we have the hypotenuse, the opposite, and adjacent. So let me say this again. Where this 90 degrees angle is pointing at, that's our hypotenuse. And the direct side of this angle is our opposite. If we had to put an angle here, all right, that would have made its opposite to be this. For that angle, its opposite would be this. And this adjacent would have been that, because the hypotenuse was still maintained to be hypotenuse. Having said that, now, how does these three trigonometrical ratios behave in a right angle triangle? How do they behave? So now let's look at this. For sine, which is sine like this, it's written like that, sine theta. For theta, we're talking about the angle inside the right angle triangle. Okay, so we have sine theta is equal to, in the trigonometrical ratio, it will be opposite over hypotenuse. So whenever you're finding sine theta, you get the opposite and the hypotenuse side. Only the two sides are important when you're dealing with sine. All right? Only the opposite and the hypotenuse are the important side when you're dealing with sine. Good. Then with cosine, which we normally do not cos, so cos theta is equal to, for cos we say the adjacent and the hypotenuse are the most important sides. The adjacent and the hypotenuse, not the opposite, no. For cos, the opposite is not needed. So we have the adjacent over hypotenuse. Then for the tangent we say tan theta is equal to opposite over adjacent. So for tan, it is the opposite and adjacent. So these are the three important trigonometrical ratios. All right. So these are the whether you like it or not, wherever you go, if you're finding sine theta, you use opposite over hypotenuse. If you're finding cos theta, you use adjacent over